Section 5.2 Operational Amplifiers. An op-amp is an active circuit element designed to perform mathematical operations of adding, subtraction, multiplication, division, differentiation, and integration. You can find a graph of op-amp at the middle of this slide. It's a chip. Actually, it is an integrated circuit. This is a typical operational amplifier chip. And normally, a chip of operational amplifier has 8 pins. And we can find a half circle on the top of the chip, and then start from the left side and with the direction of counterclockwise. The pins are 1, 2, 3 until 8. There are 5 important terminals. There are pin 2. Pin 2 is inverting input. Pin 3 is the non-inverting input. And pin 6 is the output. Pin 7 and pin 4, they are power supply. Pin 7 is positive and pin 4 is negative. And you can find the circuit symbol on the right side of the slide. Normally we use a triangle to represent an op-amp. And the inverting input and non-inverting input is on the left side, and the output pin 6 is on the right side. And how can we power the op-amp? And we should connect the positive voltage VCC to the pin 7, and we should connect negative power source to the pin 4. Normally, VCC could be 5 or 15 or 24 volts. And at the right side of the slide, you can find the equivalent circuit of the non-ideal op-amp. And there are only 3 terminals, V1, V2, and VO. V1 stands for the inverting input, V2 standing for non-inverting input, and VO stands for output. And we know the VO is determined by the controlled voltage source, A times VD. VD is the voltage difference between V2 and V1. So we get the relationship between the output and the inputs. VO equals A times VD equals A multiplied by V2 minus V1, where A is called the open loop voltage gain. Normally, the unit of A is dB. In this table, you can find the typical ranges for op-amp parameters. For the parameters of open loop gain A, the typical range is from 10 to the 5th power to 10 to the 8th power. But for an ideal value, it is infinity. The input resistance Ri, the typical range is from 10 to the 5th power to 10 to the 13th power ohms. But the ideal value is infinity ohms. The output resistance Ro, the typical range is 10 to 100 ohms. And comparing with the input resistance, it is very small, so the ideal value is 0 ohm. The supply voltage VCC is from 5 volts to 24 volts. In this graph, we can know the relationship between input difference VD and the output VO. And we can find there is a positive saturation and a negative saturation when VD is greater than expected. The op-amp can operate in 3 modes, depending on the differential input voltage Vd. The first one is positive saturation. In this case, Vo equals Vcc. The second one is linear region. In this case, Vo is greater or equal to minus Vcc equals A times Ad and is less than or equal to Vcc. The third one is negative saturation. Vo equals minus Vcc. So the output voltage is restricted by minus Vcc and Vcc. The Vo is between them. This is the end of this section.